Streaming. Go live. I think that's all I need to do is start streaming here. I don't know. I'm still not quite used to YouTube's algorithm. Algorithm? Algorithm's the wrong word. Still not quite used to the way that YouTube does things over the way that Twitch does things, but here we are. We're live. My lighting is kind of fucked up, but it works. Actually, we're not working on the planet scale stuff, so let me get out of this directory. Let me put this in my own. Or do I do this in the Rust Adventure stuff? Could probably turn this into a course later. Let's put it there. Got a bunch of courses I'm working on right now, so you can see Asteroids, Tetris, some that I've already done. This is where the Let's Code stuff goes too. The email courses come out of here as well. So yeah, let's see if they posted the information yet. Each Rusty Jam. Submissions due in 6 days. Theme: the illusion of security. Okay. Guess I can go through. Hey guys, well, how's it going? Guess I can go through what the rules are for the Rusty Jam. So you have to use Rust. Number one rule. It's kind of an unofficial community thing. I think that a couple of the people that run this are people that maintain like some of the Rust libraries and stuff. So that's kind of cool. I did join this jam. Do I need to log in? I'm gonna pull it over here for a second and log in. Of course, this is gonna pull up. How are you doing today, Godswill? Each.io. Just get a login going here. Perfect. So I've already joined the jam. We get 7 days, so it started 6 minutes ago. You have to use Rust. The theme just got released 6 minutes ago, so it's the illusion of security. I had in mind to do something like a physics-based, like either like a Super Mario 2D side-scrolly kind of thing, or like a Super Meat Boy kind of game. If you've seen any of those. I don't know if I can play any of this on stream, so I'm just going to leave it. But basically, it's like a 2D side-scrolly, physics-y kind of thing. So we'll get into that a little bit later. All of your code must be written in Rust or using Rust creates frameworks tools. I'm going to use Bevy because that's what I know the best. So Bevy is a Rust game engine, ECS based. Must be open source. So yeah, I'll go with like MIT or something like that. On top of the rules, you can choose to work with any of the modifiers. I probably won't. I mean, I'll be doing no unsafe Rust probably just by default. Rust has like 2 versions of it. Rust is like the Rust you know and use every day is called safe Rust. The Rust that lets you like go manually manage pointers and stuff is called unsafe Rust. And you use it kind of significantly less, so we're not gonna have to touch that at all. What's the standard library? Your final binary needs to be less than 5 megabytes, but you can still use STD. Okay. I don't know how big STD is in the final binary. So we'll see. We'll see if we can get ours below 5 meg. A bunch of other people were saying that they were gonna target the web. So that would be a lot more important if we were gonna target the web. I don't know if we are by the end of the game. or by the end of the week. Don't have any text in your game. I mean, I think we can do that. I don't know how much of the game we're going to get through in a week. I've never done a game jam before, so we'll find out. Connected includes some type of network functionality. If I do that, it will be there's a networking library called Backroll. Oop, that is a URL. So Backroll. Oh, is my video the thing? That's awesome. My video is the thing that pops up there. I wonder if that's just because I'm logged in. So Backroll is rollback networking. So if we do networking, we'll probably do it with this. I haven't deployed rollback or Backroll yet, so that'll be interesting. Mod support, we're probably not going to do. The Mun scripting language is something I've never touched, so we're not going to do that either, even though Mun is pretty cool. So this is Mun. It's basically like hot reloadable Rust. So the idea is basically like people use Lua for a lot of game logic and stuff like that. And this is a more rusty version of Lua, basically, which is kind of nice. And it hot reloads and you can embed it in your Rust programs and everything's all great. We aren't going to have that much logic, so I don't even think that we're going to need to use this. But it's a cool idea. Could definitely use it for a future effort. So yeah, so that's those are the rules. That's the entire thing. So let's kind of get started. One of the things that I want to use is Rapier. Rapier? I don't know how to pronounce that. Let's go dark mode. Rapier is something that I haven't used too much yet, that I'm looking to use a little bit more. So I'm thinking like something physically, where you're running around and jumping and hitting blocks and doing collision and stuff like that. So that's kind of what Rapier is. Collision detection, physics, that kind of stuff. So looking forward to getting into that. You can see there's some like stuff here. Actually, don't think I'm affecting the blocks by dragging this. Ball? Oh yeah. So you can just like hang stuff together and things like that. Probably won't be using too much of that. It's probably just going to be like collision detection and cubes, kind of like the Mario kind of stuff. Maybe some AI if we get to it. That seems like a lot though. So we'll see. But yeah, so definitely going to include Rapier. Definitely going to use Bevy. So let's get a new project started. Bevy's at 0.5 still, I believe. So if you've never used Bevy, use the Bevy API docs here to do a like walkthrough. Bevy is still early compared to like Unity and Unreal and stuff like that. It's not like some massive, huge like game engine kind of thing. We do need a name for our game. What are we gonna call our game? Chat. This one's on you. What are we calling it? It's gonna be like a physics 2D side scrolly like Mario Super Meat Boy kind of vibe. Let's do cargo new. Super Corgo. We'll have a little corgi running around or something. So we've got VS Code open. I'm using Alacrity and New Shell for my terminal, which is fun. So So we need a whole bunch of stuff here. We're gonna cargo add Bevy. We should probably see if there's like a Bevy rapier example. I mean, there probably is, right? Somewhere. Rust Bevy plugin. Get started. Bevy Rapier 2D is the thing that we need. I don't think we need any special features, any special cargo features, so we're not going to use that yet. And I bet you we can just copy and paste this in. This is basically what I was going to write anyway. So cargo add Bevy Rapier 2D. And we just swap out all of this, and we are going to have to compile. Cargo, let's just check first. Rapier physics plugin, no user data. That's interesting. Setup physics, print ball altitude. So I think the example that they had is just a ball that drops, probably. The debug renderer is very limited right now. Interesting. It can't render every shape type and doesn't render other elements like contacts, rigid body frames. Okay. Maybe we'll get into the debug renderer at some point. It looks like that's pretty easy to set up. Maybe it includes like a step through or something like that. That'd be cool. So preludes. If you've never seen a prelude before, preludes are kind of like everything the library author thinks that you need when you use this plugin to do anything. So instead of doing like individual imports for every single export, bringing the prelude into scope will kind of give you all of the symbols and stuff that you need. Let's do cargo run. It should just pop up on the screen. We've got the default plugins. We're not creating a window here that I can see, but there is a plugin. Let's get rid of the type inlays. But the default plugins do include a window plugin, so that should be okay. So I think today is just going to be like prototyping physics and stuff like that and like figuring stuff out. Going to be very much kind of like hang out, write some Bevy, write some Rust. The first build for Bevy is always quite a build because there are quite a few packages or quite a few crates that get pulled in. But yeah, so Rapier physics plugin. Maybe we look at that in the meantime. Simulated structures, rigid bodies. Colliders are something we're probably going to need at some point, right? Like we need to figure out when our little person jumps and hits a block or something like that. We need to know that they collided. So our game did run. It doesn't look like there's a ball on here or anything, which is interesting. Let's look at the getting started stuff. Here's a basic example, creates a bouncing ball on a static ground. Oh, is it just debugging that out? Okay, so it is running the simulation. It's just not rendering anything, which is really interesting. So we might have to manually hook this up ourselves to a renderer. That would be interesting. So then do we have to kind of match our sprite sizes to like the sizes of these things? It's interesting to me that they didn't include like a sprite because building sprites in Bevy are kind of easy. Yada, yada, yada. I think if we do the networking stuff later in the week, we might have to look into enhanced determinism, but other than that, seems fine. So I think when it comes down to it, this is just a simulation. So setup physics is a system and print ball altitude is a system. So print ball altitude is just logging stuff out. So at some point, if we were going to, and it's just querying for a rigid body position. So any rigid body, I guess. There's no custom struct here, right? Yeah. So this is just like any rigid body on the screen. I guess we could also query for any collider. So if we ever have more things than just a rigid body, then we probably want to query this differently. But for position of the ball, in positions.iter, since this is a query for all rigid bodies, and there could potentially be more than one rigid body, even though there isn't in this example, then set the translation of the transformation. This looks new. Vector looks different. Maybe that's added by the Rapier plugin. I'm pretty sure that the transform component on the on most sprites and stuff like that has a translation, but it doesn't have translation.vector. It has translation like X, Y, and Z. So that's interesting. So all this system is doing is every tick it prints out the where the ball is. And then in our setup physics, we have a collider bundle, which is a collider shape, cuboid. Cuboid is probably 2D cube, right? So 100 units. I don't know what 0.1 is. Let's kind of like open up the Rapier docs next to this, maybe. Oh yeah, I pulled that onto my other monitor on accident. That'll work. There we go. So we get the API docs somewhere. No? Doesn't want to give me the API docs? Do I have to go to the crate? Go to the crates. Rapier 2D. Right? No, it was Rapier something else 2D, right? I guess Bevy Rapier 2D isn't necessarily the crate that we want to go look at, because that's just going to give us like how to set up this system. Yeah, okay. It just throws us back to... So it doesn't give us the... This is what I want to look at, but I want to look at it for Rapier itself, I think. So this is the prelude. The prelude does stuff like give us all the collider objects and things like that, or the collider structs. There's a lot here. So this is a huge API surface. I guess not huge, but it's pretty big. Render. This is all debug rendering stuff. I wonder if we should go for the debug rendering first before we try to start spawning in our own sprites and things. They do have the stuff here for the features. Let's go into our cargo toml, enable that feature. Actually, cargo feature Bevy Rapier 2D. And then we're just going to use render, and it should just drop that in for us. Minus the fact that I modified it in VS Code, and VS Code might be competing for this right now. Compare. I want to take the The one on disk. Give me the one on disk. How do I get the one on disk? No. Yeah, revert to file contents. Okay, so we got render, and then we need to add the additional render plugin. I assume this is gonna like draw boxes around the colliders and stuff. Collider position, debug render. Okay, so I think we need to insert these two components on the thing that is the collider. So this, and if we run, we should see something. I don't know. We'll see. We'll find out. I hope it shows us something. If it doesn't show us something, then I'm not sure what it's doing. You can definitely see it falling on the left-hand side. But it doesn't show anything on... So are we supposed to attach sprites to the rigid bodies? The debug renderer didn't seem to do anything, which is interesting. So collider bundle, ball, spawn bundle, collider, discrete, whatever. Let's look at common mistakes. We're probably already making one. Local build, rigid body, applying force, simulation panics. None of those are what we need. Okay, so the debug renderer didn't really work, I guess. It didn't do anything for us. So that's unfortunate. I don't think we used that wrong. It's surprising to me that they include a getting started thing that doesn't like show any graphics. Because like the easiest way to debug this is not actually printing out to the console with ball altitude values. So maybe we just insert a sprite here. Maybe it'll... I can't see that that would... what size? Oh, do we do sprite without new or do we do sprite? Revy API. Why do I not have that in my history? Oh well. We'll go for sprite. We'll go for sprite. Sprite bundle, I think, is what we actually want. Bundle. And then we're going to do default here. And default is just going to fill in all the fields for us. I don't actually know what the default size of a sprite is, so let's see if that does anything for us. I think we need a spawn bundle here too. We don't need to insert. Insert is the wrong thing. Oh, you know what? We don't have a camera. Whoops. All right, let's add a camera. It's so strange to me that they didn't like throw in a camera here or something. It looks like we got a bunch of different shapes here. Capsules will be cool for like power-ups or something maybe. Cones, cylinders, balls. Balls will be useful, like little enemies shooting like fireballs or something. All right, let's go over to my past Bevy repos. And grab the camera logic out of here. Window descriptor, clear color. Yeah, let's clear this. We don't need to init resource. We do need to have some kind of like setup system that spawns this bundle. So let's get that in here. Let's pull the one that I used to, that I've used before. We'll get rid of the UI bundle, get rid of the materials. Don't need the color material stuff in the query anymore. We do need to add startup system. Setup.system. This .system thing is something that's added by Bevy. So like they have kind of like an extension trait for function types. And this system like turns the function into all the things that Bevy needs internally to run it as a system on every tick. So we get to write these functions, and then the way that these arguments get passed in is when we do these system things. Okay, so that should set up our 2D camera. I don't think we need anything else. I do want to clear the color of the background because I kind of like doing that. I feel like there should be another name for the game. It should be like Super Corgo Run or something like that. I don't know. Still nothing even with the camera. I don't think this is insert, this is spawn. But we're already spawning a rigid body, which is interesting. So like, Sync with Bevy transform. Ooh, that's really useful actually. If an entity containing the rigid body position component also has a transform component, it is possible to tell the plugin to automatically upload the transform at each frame using the rigid body position by adding the rigid body position sync component to the same entity. Okay, we actually need this. Why is that complaining? Let's get rid of the collider position stuff and we'll do rigid body position sync discrete. This should sync the Bevy transform component, which is something that all Bevy things that are rendered on screen have, with the actual physics simulation. I'm going to need to get a Core DPNG at some point here, and insert that as a sprite. Okay, still nothing yet. Sync with Bevy transform, example 2D. We do have a rigid body bundle, yeah? Yeah, we do. Rigid body, position 0, 10, so it's 10 high. Which should be, this is like basically in the center of the screen. So 0, 0 is the center of the screen in Bevy terms. Collider shaped ball. So we should have like, we do have the ball here because we do know that the ball is like engaging in the physics simulation. We just can't see it on screen. So we need to associate this with some sprite. But it doesn't tell us that off the bat. The input values are just random, so using this example as is will not lead to a useful result. Hopefully it's still a result that I can like see on screen. That's the goal here. I think we've defaulted all of this stuff except for the position, which is totally cool. 3 types of rigid bodies. Doesn't matter to us right now. Directly changing the position of a rigid body is equivalent to teleporting it. This is not a physically realistic action. Okay, what if we want to teleport, huh? Forces, impulses, or velocity modification, yeah. Ooh, I wonder if you were gonna like implement teleport in your game, if what you should do instead is like not display it on screen, but have it move really quickly and then slow down at the end. Sync with Bevy transform. That's exactly what we're doing here. Are we okay? So do we have to insert our own transform component here? Do we not get to use sprite bundle because we're using rigid body? Maybe we'll insert our own sprite component and our own transform component and see if that works. I feel like I'm forgetting something really simple. I have the UI bundle, or I have not the UI bundle, the camera bundle. Spawn bundle gives me an entity. Sprite bundle gives us a bunch of different transforms and stuff. Yeah, so we should be able to insert bundle sprite entity, or a sprite bundle, which means that we should, oh, that's in the wrong spot, which means that we should not have to insert our own transform. So we spawn the rigid body gun, the rigid body. That gives us an entity. We insert the collider bundle of components onto that entity. Then we insert the sprite bundle of components onto that entity, which should give us a visual. And then we insert the rigid body position sync so that the transform component that comes from the sprite bundle is synced with the rigid body physics. Unfortunately, that's not working for some reason. And I'm not sure why. Height field colliders, compound shapes. Position. Let's see position. Seems fine. Scene queries. Advanced collision detection. What an odd issue. Am I forgetting something completely? Let's just spawn some random thing in here. Let's drop into setup and let's spawn just like a 10 by 10 sprite. Maybe I'm not setting the size of the sprite. Let's see, color. Let's make it blue dot into. I think that should work. Ooh, blue is all caps, and we probably have to clone that. Oh no, we don't have to clone that yet. We have to do materials.add. which we didn't query for, is the problem. Materials is what? A res mute. But we don't have materials. I don't need materials, actually. Because materials is something that I just use for the 2848 thing, which is my own struct. It's not even. Here we go. That's the one I need. Resmute assets. Assets is like a database. So basically what we're saying is like we are looking at the color material database and we want to mutate that database. So materials.add color blue. This is not a return type, so we're going to add this semicolon at the end. And that should just give us a sprite on screen. It shouldn't do anything because it's not connected to the physics, but it should confirm for us that we have set up our camera correctly. Yeah, so it's there. Let me maybe take both of these, and instead of letting the sprite bundle be completely whatever it wants to be, let's make it that size in blue. Which we also now need to make this query down in our setup physics, which is no longer a setup physics function. It is now a setup things. I don't know. We'll call it something else later. So hopefully we actually did have a sprite bundle, and the reason it wasn't showing was because I wasn't adding a material for it. There we go. Man, that's really small. You can't even see that. Let me make this like, let's make this 100. And let's make the physics calculation start at, that's a shape. This is a position. Let's do like 500 here. Let's see if we can get that to show on screen. I feel like the default sprite should have a color. Wow, that's falling really slowly. And that's our cube. Eventually it'll hit the ground and then hopefully bounce back up, I think is what it did. Maybe. Oh, it just keeps going down. Why does that keep going down? Didn't the other one stop? The other one stopped at like 0.06 or something. Yeah, like when it's 10, it stops. But it only moves like a few pixels, so I don't know if you can see it on stream. That's so interesting. Okay, so if we bump this position up too high, it goes way down. Let's make it 10 times instead of like 50 times bigger. So this should go about 10 times further and then bounce, I think. Unless I just like totally messed it up. That's strange, isn't it? It never stops. The simulation on this the side over here is it just keeps going down. I've somehow broken the physics by dropping it from a higher height. Maybe maybe that's like too much momentum or something. Let's go with 50, not 5, or that's the wrong thing. Let's go with 50 here in the rigid body. So the collider is a ball, and the ball is okay, so it stops when I do 50 or so, but it goes for basically infinite when I do 100. Dang, that's so strange, right? Like, I feel like dropping it from a higher height shouldn't have that much of an impact. When does it break? Does it break at 75? That's cool though. It's interesting that it never gets to 0. It goes to like 0.6 or something like that. So 75 doesn't break it. Is it just if it's bigger than the collider shape? I think that's got to be it, right? So like 99's got to work because it's not bigger than the collider shape. And the collider shape, does it never hit the ground because the collider shape never collides if it's too big? I don't know enough about the colliders. I'm going to do some more research off stream later. Collider. Oh, that's what's confusing me. They named both of them Collider. They should have named them something else. I would have realized that much sooner. So this is the ground, which is at which is 100. So if I make this big enough that it overlaps the ground, it'll just fall forever because it never collides with anything. I wonder if I can include a little sprite on the ground here. Spawn bundle collider. Let's insert bundle here. Let's make this like super small, right? Like, well, let's do 100 for the X and like 5 for the Y or something so we can just see the ground. There we go. So the center of the box has to hit the collider. So if we go up to like 99 or 100 or whatever, the center of the box is already too low. Let's do white for this, and let's make this like 1,000 wide so that we can actually see it. And then we get our little box dropping into the... I think also the other collider is not actually as big as the sprite. So let's try to get maybe a slightly bigger rigid body. So this is a position. What else do we get on rigid body? Mass properties. Those are cool. We're probably not going to use too much of that kind of thing. I think we're going to have maybe some like it collides into a wall and you kind of stick to it a little bit behavior. But here we go. as I scroll into damping. So we can do something like create blocks of slime that you jump through that slow you down, maybe. That would be cool. Cool dominance, continuous collision detection, CCD. Acronyms, yeah. Fast moving objects don't miss any contacts. Presumably because if they're moving so fast that they would jump from point to point, and thus you kind of have to like ray between those 2 points to figure out if it would have hit anything. So if you have anything that needs that, you can enable it. That's kind of cool because it's kind of expensive. Where's the struct though? When I tried to go look for the crate for Rapier, it didn't like me trying to find the docs. Okay, here we go. Rigid body. Is it just rigid body? Yeah, it is just rigid body, but it's a rigid body bundle. Rigid body bundle is unfortunately only in the Bevy docs, or like the Bevy Rapier 2D plugin kind of thing. So let's just like try to jump there. Bevy Rapier 2D will remove all of the version information, and then this will be rigid body bundle. Here we go. Here's all the fields that we can put into the rigid body bundle. Body type, position, velocity, dominance we were just reading about, damping we were just reading about. This is the CCD stuff we were just reading about. You can apply colliders to it. So interesting. It doesn't look like there's really... Is body type the thing? No. So there's no like size here. Mass properties. Variant mass, no. So we've got a position for the quote unquote ball, which is actually just a square right now. So rip. Collider bundle, maybe. Collider material. Let's check out collider bundle. Maybe that gives us like the actual dimensions we need to match. Collider material. Can I just add the material to the collider? Like, can I just color it here? No, that's not what they mean by collider material. Shape, type, position. The shape of a collider. Arcdyne shape, okay. Arc is an automatically reference counted like wrapper to a struct or some kind of data. So we basically can like clone this really cheaply and pass it around if we need to, without actually cloning the interior. It's basically like having an ID that points to something. And like when you hand out copies of it, you're like, here's a ticket for you and here's a ticket for you. Like a what is it? I don't know. Like a line with tickets in it. I don't know. I was gonna say bakery, but like I was thinking something else. Okay, so shape new, shared shape. Shared shape has compound ball radius. There we go. That is the radius. So if the radius is 0.5, can we make the radius like something ridiculous? Like 50? Hey, what's up? Oh, hey, Nikki. Oh, yeah. I know you're Rook. Yeah. I've seen that around before. How's it going? We're getting into some Bevy Rapier integrations. I'm just kind of playing around right now, so that I can sort of get the mechanics that I'm looking for. So I'm not really building the game yet. I'm just experimenting with some stuff. I did just use the Flow Real World, didn't I? I didn't run it. You know what's really interesting? They started making sparkling water with caffeine in it. There we go. So now it's right on the floor. Oh, that's so cool. I'm so excited about that. Okay, so I kind of want to like try to implement maybe like a little jump. The thing that we're probably going to end up doing here is just putting a little box around a Corgi PNG. So I'm not really too worried about like it being like this and it being not particularly visual yet. I do want to get like some keyboard input going here and maybe figure out how to like when you jump like send that force into the thing. So we can get keyboard input. I'm just going to copy this out of here because I already have it. It's easier to look at stuff that I've already written than it is to look at the docs. Let's do what? So function like control, and we'll query for keyboard input. And then we will, if keyboard input dot, I think we want get just pressed because, well, that's not really true. So one of the things that I'd probably want to implement is the longer you hold the spacebar, the like slightly higher you jump. But I think I'm gonna do get just pressed for now. If let, I think this is a sum. Let me write this out and then it'll yell at me and then I'll know. It might not be a sum actually. It might just be. So get just pressed and versus just pressed. So get just pressed in Bevy is what you would expect from like Tetris, right? If you hit the button once, or like something you would expect from a 2048 game. If you hit an arrow key once, even if you hold it, it only does one board shift or one move. If you leave off get here and you get just pressed is every key that's currently pressed, every tick. So if you want to continuously apply some calculation, just pressed makes a lot more sense. So we'll probably move to that in the future. But for the moment right now, I'm going to use get just pressed and get just pressed. Expected opaque type found enum. I'm iterating over it here, right? Keyboard input. Oh, right. Because that's. I think I can just do if here then. Convert to carded return. If get just pressed, key code up. That doesn't seem right. What did I do wrong here? Keyword that just pressed. Where's Bevy? Bevy. Get just pressed. Iterator. Okay. We're gonna. So what I was explaining before is actually the difference between pressed and just pressed, not the difference between get just pressed and just pressed. Because the get before each of them returns you an iterator, so you can get pressed or get just pressed. But the just keyword, so like just pressed versus pressed, will give you an iterator or give you the continuous versus non-continuous. So we have a control system here. I'm gonna .add system control system. I used to like naming like these things underscore system, but I don't really think that's useful anymore. Like it's one of those things that is kind of useful for beginners. So like if you name something if you name like setup system or something like that, that can help. So you can see on the left here, whenever I hit the up button, we get the debug out. We're not doing anything with it yet, but we get it. Cool. So let's find out how to apply like an instantaneous force to the rigid body. Rigid body type, position, velocity. Velocity was applied at the center of mass of the rigid body. So as we just figured out when we put the sprite on the screen, see if I can run this again. When we put the sprite on the screen, the center of the like transform, like the 0, 0 point, is the point at which the collision happens. So we made our ball bigger, which made the collision larger. So the ball collider starts here and is a radius of 50, which goes to the edge of the square. So if for some reason this was rotated 45 degrees, it would hit like somewhere in here. But this is the floor here, kind of very an abstract floor, just a white line. But velocity is only relevant to dynamic rigid bodies. Okay, this is what kind of rigid body is this? What's the default? Let's go figure out what the default is. This is just a rigid body. This is the shared shape stuff. Where's our rigid body bundle? Rigid body bundle gives us a type of what? What's the default here? Yo. Rigid body changes, position, mass props. Come on. Give me like rigid body type. Okay, rigid body. If I can spell, rigid body type. Impl rigid body type. Is that it? Really? There's no impl default for rigid body type. What do we get then? Okay, so if there's no impl default for rigid body type, then what is the default that the bundle sets? Dynamic. So rigid body type in itself, when you construct it, doesn't apparently have a default, but the default that is set when we create the rigid body bundle is the dynamic rigid body type. So that is what we need to apply velocity, which is the thing that the docs were talking about. Velocity is only relevant to dynamic rigid bodies, no effect on static, and the velocity of kinematic is automatically computed. So at some point after the stream, I'll go and I'll check out like what is every tick equivalent to the frame rate. Yes, is what I would say. The ticks run a lot faster than the rest of your game does, right? Like, I would call, yes, after the entire set of systems runs is 1 frame, is my understanding. So you add all of your systems in, depending on what stage they're triggered in, they will all get called at some point, and then they will all be done. And that is what I personally consider a frame. I don't know if that's entirely accurate or not. So you have to do some work inside of that total frame. So like here we have, I guess, 2 systems, print ball altitude and control, right? And the work that's done in both of these systems, so print ball altitude will run and control system will run. And in this case, they run in parallel. because there's no need for them to run sequentially. They don't access the same things at all. So they will both run and then the frame will be over. So can I like set the velocity? This is telling me I kind of can. Let me do, I'm gonna start writing some structs here. So struct player, it's just gonna be a label. In the future, we're gonna actually have to derive like here. Oh, that is weird. In the future, we're gonna have to derive component here in Bevy. I think they're making that change for, I mean, for a couple of reasons. It makes it easier to determine what is a component and what isn't, and to also like determine which things should have component like logic attached to them. That seems like it's going to come out in 0.6. So let's insert our new player component here. And then what I'm going to do down here is I'm going to grab the player. And the player is going to be a query for player. Let's do a tuple here. This is going to be for a reference to the player and a, what was the thing we actually needed? The rigid body mutable, yeah, mutable rigid body velocity. So we should be able to let player equals player dot single mute. So let mute player. This is going to have to be mute, and I think that all will work out. So let's run that and see what happens. Okay, so it compiles, which is really all I was looking for. Let's do player dot. So there's a linear velocity and an angular velocity. I think that we're only going to need the linear, but let's just see what this does. This is going to be .1. Why is that angry at me? I should have the rigid body velocity, right? The field 1 on results. Oh, because I didn't handle this. We're just gonna expect this. Always expect a player. I was gonna make a joke, but I feel like leaving jokes in the code base instead of actual information or actual comments is like just asking for myself to not be happy with past me. There we go. So we're kind of like tilting it over and it's just rolling. Doesn't really do anything, but it rotates. Let's make the new linear velocity. That's an X. This is a Y. Let's make it 20. Let's comment out the angular so it doesn't rotate. So let's let this settle for a second, and then actually it doesn't matter, does it? Because I can just keep hitting this, and then it'll drop again. Blink up. Just the ever so slight rotation. Current me is 50-50 on the jokes. Yeah. Yeah. I see that. So it's interesting that this is like rotating. I don't think that I ever want it to rotate. So I wonder if I can lock the angular transform. Right? Like I want this to be able to go up and down. Ooh, okay, there's an impulse. So velocity is not actually, maybe not what we want. Forces, torque, force, apply impulse. Is this the same thing? This is forces and velocity. Where are they getting M props? What is M props? Let's see. So we've got the query for rigid body forces. Oh, the mass props. Okay. So we need a query for the rigid body mass props if we're going to do this. Which we have as the default right now. So I think instead of like directly setting the velocity, we're supposed to be setting the this impulse force. So let's do this. And we will grab see dot up. Let's comment this out actually, just in case we want to get it back. Player.1.apply impulse. Then we need the player.2 and what the impulse that it's supposed to. So this is going to be like the force. So that should be an impulse. And that should work. And it should kick our little circle square thing up in the air. I do want to like lock the rotation somehow. I'm not sure how to do that yet. Okay, it's not applying the impulse for some reason. This is like, I don't know why it's applying the force. I can't tell if it is like just doing both of them or, okay, the acceleration change is equal to the force divided by the mass. Impulses, the velocity change is equal to the impulse divided by the mass. Isn't that the same thing? In addition to gravity, it is possible to apply custom forces or torques and impulses or torque impulses to dynamic rigid bodies in order to make them move in specific ways. Forces affect the rigid body's acceleration, okay, whereas impulses affect the rigid body's velocity. Okay, so if we were going to continuously like boost forward, we would apply a force. And if we're going to jump, we are going to apply an impulse. So we should be applying the impulse. Keep in mind that a dynamic rigid body with zero mass won't be affected by an impulse. Okay, so do we have zero mass here? Did we not set mass? Rigid body position. I bet you the rigid body bundle sets a default mass. rigid body mass. Let's try to find the default rigid body mass props. Effective mass 0. Mass properties 0. Okay, so this is a thing with 0 mass, which is why the impulse is not affecting it. So let's try to figure out how to set up some mass properties. I don't know what INV is. Effective, the inverse mass taking into account translation locking. Ooh, is translation locking the thing that we need to like prevent it from? No, that's not translation though. We need like angular locking. Flags for locking rotation and translation. There we go. Rotation locked. Okay. All rotations should be locked. So let's start setting up our rigid body mass props. And let's just say default. And this is going to be, what's the actual like field that we need to set here? Mass properties. So mass properties, default. We need the mass to be something more than 0. But I also want to lock the rotation right now because we just figured out that we can do that. So we're going to do flags. What are the flags? Rigid body mass props flags. That's quite the mouthful. Rigid body mass props flags. Rotation locked. Okay, so we should see no rotation the next time we do anything. Effective inverted mass. Effective world inverted inertia squared. Local M props. Local mass properties. World space center of the mass. Oh, that's cool. Could you like use the world space center to do like, I don't know, like planets or something? Like something rotating around another thing? Sometimes it's great. Sometimes I think past me wasn't funny at all. Yes. I totally agree with that. That makes a lot of sense. So I don't know the difference between local mass and effective mass. Let's just try to set this one and see what happens. I don't know how big 10 is. So this impulse should kick off now, right? Like we should be able to. If I've set the mass. Oh, wow. I think I just set it to like 50 bajillion. Let's do 1. The 98 just crashed. Ooh. I don't know how to translate that into like Teams or whatever. But hearing that somebody crashed in Le Mans sounds not great. Okay, the inverted mass isn't the inverse mass taking into account translation locking. World space center of the mass. Square root of the world space inverse. Okay, how's this for some word juice? The square root of the world space inverse angular inertia tensor of the rigid body, taking into account rotation locking. Let's see if I can break this down. The square root, so that's just a square root, right? I don't know why it's a square root, but it is. The world space inverse angular inertia tensor. Tensors are basically arrays, right? We know that from like things like TensorFlow or whatever. So the angular inertia tensor must be the like rotation values. I don't know why it's the inverse angular inertia tensor, so I don't know why this is the inverse mass in the first place. They're fine. Will probably be a lengthy rebuild or a retirement. Ooh, rough. Effective mass. World mass. Mass. Where does mass come from? Go figure out how it calculates mass. Create utils inv local mass properties inv mass. So we need to set local inv mass. So local m props becomes mass properties. Let's get rid of this. Local m props. It becomes a mass properties. And we'll put a default in here as well. And then the inv mass, I think, is what we actually need to set. Inv mass. Something like that. Does this not implement default? I guess it's possible, right? Oh, new. There we go. Mass principal inertia. Center of mass is specified in the local space of the rigid body. Okay. So 0, 0 should be center. Initialize the mass properties with the given center of mass, mass, and angular inertia. Is there a... Changes the mass. Okay. From ball. Ooh, from ball? That's interesting. Can we do like from ball, density, and radius? Since we do have a ball on screen right now. From ball. Density, let's make the density like 2 and the radius like 10. I forget what we set the radius of the ball to. Still not affecting it. I feel like the impulse is supposed to be affecting it at this point. Apply impulse. Let's just make sure that we're getting an actual impulse execution here. So it falls, it hits the ground, we go up. Doesn't look like it's changing much. The impulse isn't having any effect. Changing the linear velocity directly is the... I wonder if we need forces for some reason. Mass properties of a ball from compound from cuboid. I wonder if there's some documentation on like the mass properties and what they mean. Typically, the inertia and center of mass are automatically set to the inertia and center of mass resulting from the shapes of the colliders. Okay, so maybe we don't need to set the mass. Maybe we're just doing something wrong with the impulse. Mass properties is composed of 3 parts. Mass, which determines the resistance of the rigid body with respect to linear movements. That's what we want. That's the thing that we care about. High mass indicates that larger forces are needed. Cool. Angular inertia determines the resistance with respect to the angular movements. So like if we were going to rotate a ball against the floor, I think. So we don't really need that. 0 is a special value. A mass equal to 0 is interpreted as infinite mass. Rigid body with mass equal to 0 is not affected by any force. And a rigid body with angular inertia will not be affected by any torque. Okay. We definitely don't want torque. So we chose the right thing to apply the impulse to, as far as I know. Computing mass and angular inertia can often be difficult because they depend on the geometric shape of the object being simulated. This is why they are automatically computed by Rapier when a collider is attached. Okay, so we don't actually need to set the mass. We just need to make sure that the collider is actually applying that mass. Okay, so I think that we're doing something wrong when we're applying the impulse then. Because what it's telling us is that we shouldn't need to set these mass properties at all. The collider, when we call it a ball, should be setting those mass properties for us when we insert the components relative to the rigid body. So when we press and we apply impulse, maybe these need to be either bigger or smaller. Let's make them bigger first. How's the rest of the Le Mans going, Nikki? Okay, so if we go up, something's happening. Very slightly, something is happening. Okay, so let's see, 1,000. What did we say the collider was? The collider is 50. We need 1,000 force to move a 50 ball. That's interesting. We do want to lock the rotation though. I did notice that the rotation was not locked anymore because we commented this out. So what I will do is put the defaults here and we just won't set the local M props. And hopefully this will cause it to not rotate because we really don't want it to rotate. That number goes up so barely. Wow. Is this just like a ridiculously heavy ball? Is that what? Oh, you know what? That's XY. Let's do like this and throw it into the air if we can. Enjoyable so far. It's 24 hours, but there's no sign of drivers taking it easy. 24-hour sprint to the finish. Oof. I couldn't drive for 24 hours. Like I've driven for like 15. I've driven for like 18. It's not fun. Not at all. Okay, so this is barely moving this ball. Like it is moving this ball, but it is barely moving this ball. Like this force needs to be so gigantic that I'm starting to feel like I set something up wrong. Or maybe that's just it. Maybe instantaneous force does actually need to be so large. I mean, that's true with something like high jump or whatever, right? Like the instantaneous forces are so big. Oh, 3 drivers per car. Okay. I mean, that's better than I thought it was. So we've got the world's slowest jump animation here, but it does work. We've got double, triple, and quadruple jump, which we'll probably have to lock in at some point. With maximum continuous times that are enforced. Oh, that's really good, actually. I feel like driving gets really dangerous, like over 12 hours. And I could imagine that like driving under intense pressure like that gets dangerous a lot sooner. I'm just having fun making this little box go up and down. We have our physics working. It's wonderful. I'm very happy with that. We do need to like be able to run back and forth. And this jump is like ridiculously slow. So we need to increase like gravity, I suppose. I'm not sure. I'll have to look up how to like this is just the experimentation of getting it to work. So making it like feel smooth and nice when a player jumps is going to be a very different thing, I think. But we do have a jump. And I suppose we should get left and right moving, right? Like left and right are probably forces. So let's go back and look at forces. And this is force, which means that we need to query the rigid body forces. There we go, rigid body forces. Let's put this to the end so that I don't have to change my numbers. And then the rigid body forces. Doesn't look like we have to like do much here. So let's say this is just whatever. And then we have another thing down here that's like if keyboard input dot pressed key code left, then we do this kind of thing, and then the X will bump up a little bit. I feel like we're gonna have to. And then this is going to be what, player dot 2, 3? Yeah, 3. So this is with any luck, this will be the right direction for both of these things. But I doubt it. Yeah, they get out and are knackered. The before after pictures are eye opening. Oh yeah, I could see that for sure. That makes total sense to me. Okay, these are not going left and right. I feel like the forces are way too small. So we aren't getting left and right. Is there anything we need to do about these forces? Player 3.force. Yada yada yada. Dynamic. It is strong enough to make the rigid body move. That's exactly what I'm doing right here. Rigid body has non-zero mass or angular inertia. So the question, forces and impulses. Let's bring these way up, like ridiculous amounts of numbers up. I hope these are float 64s. I think they're float 32s, which should still be big enough, but oh, there it is. There it is. Our cube is moving and it's flying off the... Okay. No, get back up. Get back up. Get back up. Oh, not that high. Not that high. Not that... Okay. All right. It's still going up. Well, it works. And we learned that the floor actually isn't that big. Okay, so I feel like one of the things that we need to do here is apply an impulse to like start off. So if we go left, I think we want to set like a negative... Wow, I'm gonna need to change these numbers because holy... let's start off with an impulse when we go left. And let's start off with an impulse when we go right. And let's see if that changes how the experience of like going left and right feels. Because I feel like... Yeah, there we go. Now it actually feels like I can stop it. Although it's still going up and I don't remember jumping. It's coming down. I don't know what X value it's at. So hopefully it's just like in the center. There we go. So that's cool. I like the idea of like the momentum where like you're running, and then like I feel like it can't be, it has to be capped. Like the top speed has to be capped because otherwise I don't know how I'm going to generate the impulse to like stop. This is a very, very slow jump though. I think we lost it. I think it's off the screen somewhere. I should be logging out the X and the Y value as well, but I am not. Yeah. We lost it. It's gone. Okay, so we're gonna not change the angular and linear velocities like that. Is there a way to cap it? Let's see, damping. Fake air friction. Dominance. Dominance is something that they said should be like player. Oh, one of the things that I want to do before we get into the next piece is make the floor a little wider so it doesn't like flop all around. Let's see. This is the collider for the bouncing ball. This is the ground. So let's make this just like all wide, like across the entire thing here. I do want the like the left and the right top speed need to exist though, because like I do want it to be like I do want it to drift a little bit like this because I want it to be a little physicsy, but I want it to drift more like this all the time. where like it's a kind of a deterministic amount that you're going to slide rather than like this, which I'm hitting it now and it just like flies off the screen, right? Like I don't want ice. I want something else. So I guess we want like a max velocity. Only relevant for dynamic rigid bodies. Can we like cap this? Because static and kinematic bodies are immune to forces, they are not affected by gravity. Makes sense. So like should we be able to take this velocity and just be like, hey, it can't go above whatever, whatever? I don't know what that will do to the like the inertia. I think maybe that's something that I look at later. Rigid bodies are also automatically woken up whenever the components of the rigid body is modified. Cool. Okay, so like we're doing pretty good here with the rigid body stuff. All components of the collider bundle can be queried and modified from Bevy systems. Cool. Solid colliders are geometric shapes like the one that we have. They have contact points with other colliders to generate contact forces, which is like the floor and the thing that we have in our scene right now. Sensor colliders don't generate contacts. They only generate intersection events. So like this is a gate, I suppose. Yeah. So like on the first level, we could have a sensor collider like one or half a scene length to the right, and it really only starts the level after you hit that point or something like that. Shapes, triangle meshes. What is restitution? How elastic or bouncy a contact is. Ah, cool. So like ooh. So this is what we want for our player. Actually, we want a restitution of 0 against the ground. How do we set restitution? We jamming. Hello, Xander. So check this out. We got physics stuff happening. All the movement is like way overblown and like way too much, and the jumping is like super slow. This is like feather falling kind of thing, or like everybody's in space kind of moment. But we have acceleration happening for left and right. I want to cap the speed or cap the inertia or something like that. The thing that I was just looking at is when you jump, it lands back on the ground and bounces. And I don't want it to bounce. Like I don't want the player to bounce. So there's something called restitution. that I can set somehow. So restitution is 0.7 on the collider. So where's our restitution? I think this should be 0. Some rapid terminal output. Yeah, well, it's a physics simulation, right? So it's just telling me that the ball position has changed on every tick or hasn't changed on every tick. So every time there's a thing printed out there, it's a tick of the physics system that is running. Gravity isn't very strong. Like I do want it to get that high, but I do want it to fall as well. Where's our what's going on with gravity here? Rigid mass props. Maybe we need to increase the mass. If we increase the mass, though, we have to increase the forces used. And the forces I'm using right now are like 200,000 for jumping, which feels like a lot. So I'm not sure how to adjust the things that we need for that. But I'll figure that out probably later at some other time. Okay, so that's all cool. Collision types, events, so we can tell when something collides. Event handlers are user-defined callbacks used to be notified when two colliders stop touching. By default, no contact event or intersection event is generated by the narrow phase. In order to enable a contact or intersection event for a pair of colliders, at least one of the involved colliders must have the corresponding event set as active. An event is activated for a collider by setting its corresponding active events bit to 1. Okay, so we need to be able to set up some kind of query where it's like is on the ground, right? Because we don't want it to be able to do double jumps, I think. I think we're just gonna have it do a single jump. Maybe that's something for later. Let's do scene queries. Raycasting. Raycasting is cool. That'll be. I don't think we're gonna have any bullets necessarily. I think that maybe. Ooh, if we wanted to do something like only show the pieces of the like level that you could see, that would be a use for ray tracing. I don't know what I'm gonna do for the levels yet. Like it could be in a cave, right? The theme for the thing is the illusion of security. So maybe we do like a bunch of locked doors and stuff like that. I don't know. We'll figure it out. I need to come up with an idea. I think the mechanics are the thing that I need to figure out today. And then I'll do some thinking about like the actual game itself. So ray casting, shape casting. I don't know what shape casting is. Oh, we can. Okay, that's cool. So if we were going to I don't know what we would use shapecasting for, actually. Point projection. Okay, so is this a Bevy query for things that are colliding? Okay. Query pipeline collider components query. So we have to do that inside of a system. So we don't get like a Bevy query for that, but we have to just like get the resources to make the query and then make the query ourselves. I don't think we're at advanced detection yet. Okay, so we're doing pretty good. Gravity is presented as a vector. Gravity can be altered at each time step. That's kind of cool. Okay. Integration parameters. Tracking what's still moving. Physics pipeline. Collision pipeline. Query pipeline. Cool. So we're doing pretty good here. I think that I don't think that I need to look at the N algebra stuff. Ooh, GLAM is also the library used by Bevy. Ah, the gated mead with the trodden path right around it. I don't think I'm familiar with that one, actually. Okay, so we can jump infinitely, so that's a problem. Okay, maybe I start creating some issues on the GitHub repo. So did I create a GitHub repo here? No. Am I gonna name it Super Corgo? I guess I will name it Super Corgo. I could always rename it later. Hub create. And then we'll take the source and the cargo files and the git ignore. We have working physics. Change the branch to main, push to origin main. And then that threw that up on my other monitor, but the repo is up now. So let's see. Let's start creating a couple issues here. Let's do currently the player can jump infinitely. Should only be able to jump if is in contact with a surface. So like I'm thinking Super Meat Boy style, right? Like if you can land on a wall, you should be able to jump again. But if you're like in the air, you only get one jump. And then the jump is sluggish, right? So that's another issue here where, let's run the game. Cargo run. I think I'm only going to create one level. So like this thing falls so slowly. And like if this is going to be a like a jumping whatever, this is bad. We need to adjust the camera too so that the ground is actually at the ground and not in the middle of the screen. See, jumping and falling is slow. Should be responsive. Let's use words that mean nothing. Let's see, new issue, floor of level should be at floor of camera. Right now it's in the middle of the screen. Let's take a screenshot of that because that seems useful. What else? We need to, what? Be able to run back and forth. Oh, max speed. Let's do the max speed one. So max speed is uncapped. When running left or right, the max speed based on the forces is uncapped. Results in really long slides when changing direction. Max speed, or maybe max force? No, not max force. Or maybe filtering the force out. Capped to some value that makes gameplay fun. So that's the left and the right here. Oh, the square is off the screen again. The camera should follow the player. How's that? So this left and right, like if we're just doing it like right here, it feels kind of nice. It's fine. Like, but if we do longer, it takes longer. So I feel like that force is just building up and building up and building up. And like sliding for this long forever does not feel fun. So I want to change that. Player should be the party corgi. Sprite needs to be modified to be a corgi PNG or a corgi animation, right? Like we already have the animation steps, so maybe I can just pull this in as a sprite sheet and have it like when you're going left and right run. We don't have we don't really have a jump, so let's see what else. So we've covered jumping, we've covered movement. We haven't done any like levels or anything yet, so we need to figure out how to make levels, right? Maybe we start with some obstacles. Maybe we take something directly from like Super Mario and just put blocks on top. That you can jump up into. Which implies some kind of points and lives system, right? I don't want to just like straight up copy Mario. So one of the things that we do need to do is like figure out how we're going to fit into the theme. The illusion of security. I don't know. I'm going to have to think about that one. It's going to be like you think you're safe, but you're not kind of thing, right? I don't know. Maybe like floor mechanics that. Ooh, let's do this. Let's do an issue for multiple floors. And gaps. So let's do something where you need to. Player should need to jump over gaps. Colliders should be at bottom of pit. To take a life away. Let's see, the camera needs to follow the player too, somehow. I think. Similar to something like Mario, where the player can only ever get to like 90% of the camera. So like that's not entirely true in Mario, where you can like get the camera to stop at the beginning and the end of the level. And run off the screen while it's doing that. So we'll see what we end up doing. Long X coordinate. I don't know how that's going to happen. Like we have the camera, right? And I think the camera has a transform. So when the player runs, if the player is somewhere in the middle of the screen or something like that, we can move the camera left and right to reveal more of the level. First, we have to have a level 2 reveal. So I think we need to do the other thing first. But one of the things that could be cool after we figure out how we're going to do the levels is do like a maybe a JSON representation of a level and be able to like load it in. So you can kind of create your own level. All right. Well, I'm kind of happy with where we got for right now. I'm going to do a little bit more research into Rapier and Betty, and hopefully I can get a little bit more of the mechanics done. I'm going to take a break from the game jam and then probably do some more work either later or tomorrow. I'll just start cranking out on these issues, and hopefully we get something that is like fun to play in a couple days. Thank you everyone for hanging out. Thanks for coming to see the stream, and I will catch you probably tomorrow. I'll probably stream again tomorrow. So we'll see. Later.